Okay, good morning, everybody. Today, what we're going to do is we're going to talk about sampling distribution for two means. It'll be a difference in means is what we're talking about. Let's take a look at our example. Example we worked on in class. Which school is better? ACT scores at Ardrey Kelly School, High School are normally distributed with a mean of 26 and a standard deviation of 3. ACT scores at Providence High School are skewed to the right with a mean of 25 and a standard deviation of 5. So if you think about it, this one is what the Ardrey, I spelled that wrong. Ardrey Kelly, sorry. They're normal. So it got that bell-shaped curve centered at 26, standard deviation of 3. So I added my 3's and subtracted my 3's. And that's Providence. Providence is skewed to the right, centered at 25. Got your standard deviations there. So those are our two standard deviations, our two distributions. And what we're trying to do is we're trying to see which school is better. So looking at this right now, these have a higher mean, but these go up to a higher score, I guess is a better one, if that makes sense. But let's take a look and see how we figure that out. So to determine shape, the way we determine shape is there's two checks. The first check is if the population is normally distributed, our sample is normally distributed. So in this case, Ardrey Kelly High School is normally distributed. So what I can say is that the sampling distribution is approximately normal because the population is approximately normal. Okay, so what we have here is because it says normally distributed here, I can say that all of the sampling distributions are going to be normal. PHS, Providence, it's skewed to the right, so it's not normal. However, this thing says we're going to take 30 students from PHS. So in this case, our sample size is greater than or equal to 30. So by using what's called the central limit theorem, we kind of looked at that visually last time. A central limit theorem, I can say that the shape is approximately normal of the sampling distribution. So what's going to happen is as I take more and more samples from that skewed right distribution, the X bars I'm going to get end up kind of forming a normal distribution. Okay, the mean. If we look at this, the mean has everything to do with random. So in this case, we randomly selected 25 and we randomly selected 30. So what that says is that the mean X bar is equal to the true mean. So in this case, for AKS, the real mean is 26. So we can say the center, that's 26. So that's our first sample. We can do the same for our second sample. It's going to be the same as the original, so 25. Standard deviation is where we're going to do our independent check. And our independent check is going to be the 10N check. And the way we want to look at it is we would say 10 times 25 equals 250. We want to compare that to the population of this high school. I think it's safe to assume that a high school would have more than 250 students. 250, I would assume. If not, we're going to go out on a limb and say, I will assume that there are more than 250. So I'm assuming more than 250 students. So what that does is it allows us to use this formula, and it's a much easier formula to work with. The formula is the population standard deviation divided by the square root of the sample size. So in this case, so whatever it was for our first one divided by the sample size, so this one is going to be 3 divided by the square root of 25. This is going to be about 0.6. And we do the same thing for Providence. So we'll do 10 times 30. That's 300. We're trying to see if that's less than the population. We're going to assume more than 300 students here. So then what we can do for this one is use that same formula, but in this case, I'm going to do 5 divided by the square root of 30, and 5 divided by the square root of 30 is going to give me 0.91. It's going to give me 0.91. So this is one sampling distribution. So AKS is normal. If I take a sample of size 25 from AKHS, I'm going to be normally distributed, centered at 26 with a mean of 0.6. If I took a sample of 30 over and over again from PHS, from Providence, I'm going to be normally distributed, centered at 25 with a standard deviation of 0.91. Okay, so the thing I want to look at when I look at these right here, these are two distributions. These are two distributions I can look at, but what I really am interested in is I'm interested in the difference between the two. Now, here's the deal. Let's look at what would happen when we subtract. Because we did these verifications, I can now answer these questions. The mean between the two distributions is like using our rule. I'm allowed to just go ahead and subtract the two means from each other. So x1 minus mean x2. So I can do 26 minus 25. I can do 1. The difference, so the sampling distribution of the difference of if I were to combine these two distributions by subtracting Providence from Ardrey. So that's our mean. Standard deviation, again, these formulas are on your formula sheet. So what I'm allowed to do for standard deviation is the first thing I need to do is I need to turn them into variances, add them, square root to bring it back to the standard deviation. But realistically, it's a plug into the formula situation. So what we're going to do is we're going to take the standard that's M1 down below. We're going to take the standard deviation of our first one. We're going to take the standard deviation of our second one square. We're dividing it by the sample size. This is our formula. We're going to plug in the numbers. So this would be 0.6 squared divided by 25 squared plus 0.91 squared divided by 30. This is considered work, folks. This is the piece that I'd want to see for work. And then when we plug that into our calculator, we end up with 1.09 as the standard deviation. So the difference between the two is 1, but we have some variability of about 1, a little over 1. Now the shape of this distribution. Because both sampling distributions are approximately normal, the difference is also approximately normal. It wouldn't have worked if I tried to subtract the two populations from each other because it's a normal and a skew. Normal minus skew doesn't become normal. But since these two sampling distributions are normal, I can then say their difference is normal. So what I've actually figured out is this. I have a normal distribution centered at 1 with a standard deviation of 1.09. So realistically, what I have is I have a sampling distribution that looks like this. This is for the difference. This is going to be for my difference between the two. It's going to be normally distributed. It's going to be centered at 1. And now what I can do is I can add and subtract those standard deviations. And those standard deviations are, this is going to be 2.09, 3.18, 4.27 as I add. It's going to be negative 0.09, negative 1.18, negative 2.27. So that's what the difference looks like. That's what this distribution looks like visually. So now what I can do is the question says, calculate the probability that a random sample of AKHS has a higher mean than those people at PHS. So again, higher mean. If it says higher mean, it means that it is greater than 0. So what I'm going to do is I'm going to go find 0 on here. So 0 is going to be like right about there. I want to figure out that area right there. I want to find out that the probability that the difference between my two distributions is greater than 0. And what I can do is I can go do normal CDF. I got a lower bound of 0. I got an upper bound of a whole lot of 9s. I got a mean of 1. And I got a standard deviation of 1.09. Break out my calculator. I do second bars. Do normal CDF. 0, lots of 9s. 1, 1.09. In this case, it's about 0.8205. So this tells me the probability of ending up with a higher score from 25 people at our Ardrey Kell is greater than Providence is about 82%. So this demonstrates that it's likely that the Ardrey Kell is a better high school in terms of the ACT scores. So that was the lesson. That's kind of what we worked on in class. The next video kind of worked through the example on the back. So please kind of watch that after you've practiced the video. Again, send me emails if you have questions. We are going to review next class and get ready for our test next week.